for me, I had to figure out a way to be able to run it off of grid, to run it off the inverter and batteries, to plug it in when I wanted to, and have it switch, or only use this as a backup. And when I was in a location that I only had a little generator, I wanted to be able to use it to charge also. So that allowed me to connect it to my Chargeverter, either through a big generator or through a little tiny generator. None of it mattered. I needed it to work in all situations. And that is what we're going to talk about in this video, how I connected the original RV grid plug to my inverter to allow all scenarios to work the way you want them to. So as you can see, this is the original plug that comes with the RV. It's a 50 amp 208 three-phase or 120 240 split phase pole from a standard pedestal like this one over here. It basically takes the standard plug-in, twist, lock, and that's kind of what this RV always used, which is why I went with the inverter that I went with, because it fit the RV. It's very important that you understand the plug that you have here. In RVs, you have these 50 amps that are 120. You have the 50 amps that are 240, 120 split phase like this one, or you have the 30 amp plug, and then you have the 110 or the 120 15 amp or 20 amp, whichever one they have. So you can see those. In a typical pedestal, you can see those in a typical pedestal here, where you have the 20 amp breaker for the 20 amp plug, the 30 amp breaker for the 30 amp plug, and you can see that has the odd looking plug with the diagonals in it, but it does say 30 amps right there on it. And then this will be the 50 amp plug that runs to the L1 and L2 side of the breaker here, the L1 and L2 side. So that's the 20 amp going to the 20 amp breaker, the 30 amp going to the 30 amp breaker, and the 50 amp going to two poles, L1, L2, and the 50 amp. Now, the 50 amp one that I'm talking about uses this plug right here, and it, on the other end, plugs directly into the RV. It's very important that you understand the difference between the 20 amp plug, the 30 amp plug, and the 50 amp plug, and which one of these your RV is using, and what kind of breaker box is located inside the unit. That will allow you to pick the right equipment to get your solar system set up. In my case, though, we are talking about a split phase 240 volt with two legs, an L1 and an L2 at 120 volts apiece. So here you can see, this is where I took the battery vents. There were two vents with a screen cover that went over here that went down over top the original 12 volt batteries. I took those 12 volt batteries out and replaced them with the Victron Orion systems. I'll put a link to that up there. But basically, each one of these plugs has a different purpose. So this one is the other end of the plug for that, or not the other end. This is the plug that plugs in where the original RV plug. So I mounted two of them here. The first one, this one being this one, is a replacement for grid power. Now I did it up here so that we could manage the distance of the wire. And I'll get into that here in a few minutes of how long the wire was and what needed to be run for that wire exactly, because that was really the expensive piece of all of this. And it's very important that you understand it. So we'll get to that here in a few minutes. But I have two different plugs here. The bottom plug is another 50 amp, 120, 250 volt plug, and the top one is a 50 amp, 120, 250 volt plug with grounding, meaning it's a 4-wire, 4-prong plug, ground, neutral, and then two hots, red and black. And you'll see that on the diagram that is either here in the video or attached in the email list. If you're not part of the email list, you should go sign up for the email list, because this will be one of the items that I send out in the contents, is any of the PowerPoint presentation with all the pictures and diagrams of exactly how this is wired will be attached in that email list. So you're going to want to do that. But the bottom one here, this hooks up to the grid. It runs directly to the inverter and connects to the grid on the inverter in this compartment. As you can see, we're only a couple of feet away. The top one runs into the chargeverter, or it can also run into the generator. Now, the generator can be hooked up through this and charge it, or you can use the grid to charge it. Now, what I have done is I use the plug to use the chargeverter depending on where I am. If I just want to, if I only have lower amounts of power, I'll use the chargeverter. If I only have a 110 or something and I don't actually have a 250, as you know, the 600 XP is very particular about having clean 240 volt power with all four ground, neutral, positive, negative available. So the one way to solve that is to run your generator and your other power directly through a chargeverter, which I did, and it's right inside this compartment. But I use, for when I only have a 110 plug, instead of plugging the chargeverter into an adapter right inside the building here, where it's a normal plug that connects directly to this one, the 30 amp here, I instead use this adapter, which is made based on EG4's suggestions of a 30 amp, or excuse me, a 20 amp plug. So this is a 20 amp cord, and as you can see, the plug is a little bit different. One of them is sideways, and when I only have 15 amps available, I use this adapter that adapts it down from 20 amp to a 15 amp plug, which is a standard wall plug, meaning I can just use a standard generator that generates, 1200 watts if I want, and plug it in and use the chargeverter to charge things. This plugs directly into the chargeverter this way, as opposed to the port that I have in there. And once this is plugged in, then you can plug it straight into an inverter. So I built two plugs here to serve both needs. The purpose behind doing it here is that the cable wiring required to reroute that one back there, it is a 42-foot trailer. And with 42 feet from that end to this end, I would need about 50 feet of cable to get it up through the bottom piece and mount it into here. And then I would need an additional, if I wanted to run two of them, I would need an additional 50 feet to put the second port in. So I opted for leaving that in place and not doing anything with it. I basically take this one here, the grid connection, and I run it straight to the inverter, grid in. That way, if I want grid power, it's as simple as plugging it in here, just as it would be there. And then that has the bypass switch included in the inverter. And there'll be a diagram for that also in the email packet, or hopefully I'll be able to show it here on the screen also. But that grid, this provides grid for bypass. For if I'm in a park, there is a misconception that if you're in a park, then it's an off-grid inverter, that it's going to require you to run it all the time, which is not true. You can set the 6000 XP to charge 24/7, and when you plug the grid in, it automatically goes into charging mode and goes into bypass mode. And when you unplug it, then it would go into running off a battery. So it isn't a necessity that you only have the grid hooked up and you have to do a bypass and all that. Let the inverter do the bypass and treat it like a real grid situation in an UPS mode, which means a backup power mode. And when the grid is out, like it is now, click, then the inverter goes into run off the batteries. And when you plug it in, then it would switch back to grid mode. I run off-grid 24/7, The only time I hook this up is when I'm testing something, when I'm playing with something, or when I know there's going to be excessive power uses, like around the holidays when my wife's going to be cooking a bunch of stuff, and I want to make sure that it goes into bypass mode instead of shutting down and having me reset it. Those are really the only few cases that I do that. Otherwise, if I'm in a park and I have really low power, I may run through a generator like this if I'm lazy and only brought the small generator, or I can plug in this to a normal generator and use this plug up here and plug it into like a 240. I've got a Predator 9500, which the 9500 is actually big enough to run off of either port. I can either run the whole system off of it in normal bypass mode and charge mode, or I can run it off of the generator port also, which is nice. And if I run it off the generator port, then it runs not to the generator in the inverter, which I could have done, but because the generator in the inverter doesn't really take clean power, it only takes clean power of 3% harmonic distortion. I chose to intercept that with the Chargeverter, and the Chargeverter is a much better solution for that. That way, no matter what generator I'm using, I can use a cheap $600 7,000, 8,000 watt generator, plug it in, let it run full speed for a couple of hours, charge everything up, and then shut it off and not have to worry about it anymore. Now, here is where, in this particular park, a lot of the times the power can be located anywhere. This particular park, it just so happens the power is right there. And this is the port that was originally wired into the fuse box, directly to the fuse box, to supply grid power. Now, my inverter is located way down here, and it is a 42-foot RV, and if you take it all the way to the end, it is just inside this bay door. So what I didn't want to do is I didn't want to pay to have both cables ran underneath this RV in the under bay for 42 feet. That's over 100 feet of wire. And the fuse box that it's ran to currently is approximately right here on the far side of the RV. So as you can see, this is probably 15 feet over and then another 2 or 3 feet across to get to that fuse box. And because of that, I chose to run one cable from the inverter. And if I come in here to the inverter, let me see if I can show you this real quick. I think I got this panel already loosened, so I can just pop it off. One panel. So one of I showed you earlier the two ports over on the side. One runs to the input of the electrical coming in from the grid, and the other, and you can see that on the case here. Let me just show you that case real quick so you'll understand what I'm talking about. You can see here we have grid and there we have load. So I have 6-aught coming in from the grid all the way to the back of the RV. And I did use 6-aught instead of any other size. I'm very uncomfortable with the 50 amps of any consistency running that isn't on 6-aught. I know some people say that you can use 8-aught. And if it's fairly short distances, I would have no problem with that. Or if it was minor spikes, I'd have no problem. But I will not do it in an RV that I'm sleeping in overnight without it. So this has the 4 wires, the black, the red, the white, and the ground. And then this one is the load. The load runs back down the RV to the original spot where down where the fuse box is on the far side of the RV from this spot here. And it runs into that, and I'm going to go into great detail in there on exactly how that's wired and show you it also. All right, here we are at the fuse box. Now, let me show you, and you can see from the diagram where this fuse box comes in, but I wanted to show you firsthand exactly what we're looking at. So this is the 50 amp breaker position where they come in. The red and the black come in here, and then underneath this panel, and I'm going to pull the cover off and show it to you. But you can also see here, this is the WFCO, or whatever, however they pronounce it. This is the model WF8930/50. There'll be a parts list, and the parts list will have a link to it if you're interested in a replacement or getting one of your own. So I'm going to pull this cover off, and when you do this, you expose all of the wires behind it, and this panel is still hot, so I'm not going to touch anything inside or get near anything, but I do want to just show you what it looks like inside and explain where the wires come in and where they connect and what I replaced. So the original 220 watt from the back corner of the RV came in and connected where these two wires, this black, this red, this white, and then behind it is another bus bar with the ground wires. And so it came in and connected there. I disconnected them and left them underneath the bay, laying in place, and strapped them down so they wouldn't go anywhere. If I ever decide to just switch this back or get rid of the solar system, it'll be very easy to push the wires back up through the bottom and reconnect it here and be back on normal grid mode and not have to worry about it if I ever decide to do that. But this set of wires here runs from the inverter, and that was the output of the inverter that said load out there. And you'll remember when we hooked up the wires, the load, there was two sets of wires going into the inverter out there. One came from the grid, and one came from the inverter, went to the load, which is here, the breaker panel. The other plug that I had out there, just for clarification, the other plug that I had out there ran straight to the Chargeverter. It did not go to the grid because I couldn't guarantee that I would have clean power. So instead of dealing with it that way, I ran everything through the Chargeverter, knowing that that was going to be able to pull about 5,200 watts is what the Chargeverter is. And I'll include a link to that in the parts list also, just in case you're interested. But as you can see here, this is a standard double pole 240 split phase breaker. The difference is on this panel is it doesn't have the cross breakers above each other, allowing you to hook up a 220 plug or 220 normal outlet to it. Everything is split where for L2 goes to the left, L1 goes to the right, and therefore you're only allowed single pole connections to do it. That doesn't mean that with a different breaker box you couldn't have 220 volt appliances, but in this particular configuration it doesn't allow for it, and it does allow for a nice tidy little box though where all the wires come in. You can also see here that I put in a couple of meters in here, and those meters, the Shelly meters, are basically for the refrigerator and the island, which has the coffee pots and stuff. So I was curious how much energy those use. On the other breakers where I did the air conditioners, and you can see here, it did have the air conditioner set off onto two different breakers. So there's one here for second AC, and there's one here for primary AC. I pulled those wires out of the roof, put the mini splits in, and if you're interested in the mini splits, there's a different video for that also. But the so this rewired these, and you can see here that the 1, 2, 3, 4th plug in, being this one here, looks just like all the others, but it does have a new wire down there. I don't know if you can see it. It is a bit of a marine grade wiring instead of your standard copper wiring. A lot of the RVs put the solid copper wire in, and based on the knowledge that I have of it, copper wire, if it wiggles a lot over a long period of time, has a tendency to break, and that's why it is said that you should be using stranded wires in an RV. So I always use stranded wire. Now, that said, a little disclaimer, I am not an electrician. This is what I did. Don't take my word for it. If you're uncomfortable doing what you're doing, hire an electrician, and do not do it yourself if you're not comfortable with everything that you're doing. I did this for mine, and it may not apply to you, or it may not be totally correct. And if that is the case, I would hate to hurt you or have some damage done to you. As you can see though, it is a 240 split. So in that case, the wires run, as the new diagram will show you, run from the new plug up front to the inverter, from the inverter to here, and thus eliminating all of that extra wire that I had to do, but giving me the ability to run in bypass mode when I want to, charge mode only when I want to, or to run everything off grid and only use the grid as a backup, which is, if I'm going to use it, that's how I use it, for that and for bypass. Or I can even use the Chargeverter, which I have hooked up to the 6000 XP, to detect when the batteries get low, to automatically click on a relay. And I'll have another video for that also, how the relay and the Chargeverter works, because that's a very interesting setup that a lot of us were working on when I built it. So I think that's it. If you have any questions, if you have questions about the panels, about the wiring, about the things, make sure you check out the parts list. Make sure that you put the comments down below, or join the Discord server or the email server to get into all the extra content, and I'll be glad to answer all those questions. Thanks a lot. Well, thanks for watching. You made it to the end of the video. Please make sure you like, comment, share, and subscribe at this point, because it's time to move on to another video. We'll see you on the next one.